Okay, so we're going to be talking about scatter plots and correlations. And when we're talking about a scatter plot, okay, it says a blank, a scatter plot, okay, a scatter plot is a graph with points plotted to show a possible relationship between two sets of data, okay, between two sets of data, okay. Now, what we really are talking about here is we have something representing our x values, something representing our y values, and we're trying to see if there's some kind of a relationship between them. Does one go up as the other goes up? Does one go down as the other goes up? Is there no relationship between the two and we just have a bunch of points randomly plotted on our graph? And so what we can take is, for instance, this example here where it says increase in list, and we have a calendar year versus species, okay? And we can see if there's some kind of a relationship that forms, okay? Now, we could call the calendar year our x values and the species our y values, and then start to plot them on our coordinate plane, okay? Now, since this is our calendar year is using years, 1996, 1997, we might start with the year 1990 and then just go up by 1 year every year since. So I'm actually going to start with 1990, but then we'll go to 91, 92, 93, 94, 95, 96, 97, 8, 9. Then, of course, we hit the year 2000, 2001, and 2002. Okay, and so that accounts for all the years that we have listed here. And then with species, we're going anywhere from, it looks like, 9 to 91, so maybe counting by tens would be good values for our y-axis. So we're going from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, and then again, our x-axis were represented by the calendar year. Okay, so labeling our axes. Okay, we're represented the calendar year, and then our y-axis represents our species. Species. Okay, so this would give us a good start in order to plot our points, in which that would create our scatter plot. Okay, the relationship between the calendar year and the species. So our first point we see is 1996 and 91. Okay, that's our x and a y. So if I go to 96 here, we're going up to about just a little past 90, 91. Okay, 91. Okay, so that would be our first point. And we have 97 and 79. 97 and 79 would be just below 80. Just below 80. Okay. So we have 96, 91, 97. We have 79. 98, we have 62. 98, we have 62. So just a little above 60. Okay. Then we have 99 is 11. 99 is 11, so just a little above 10. Maybe a little bit closer there. There we go. So just a little above 10. And then we have 2000 is 39. 2000, we're going to be just below 40. Just below 40. And then 2001, we're at 10, exactly on the dot. And then we have 2002 is 9, just below 10. Okay? Now, this would represent a scatter plot, okay? So we took our points, we plotted them, and notice it is a little bit scattered, okay? It doesn't necessarily have a form to it. Although, in general, if we look at the graph, it tends to go down as we move across the x-axis. It tends to go down as we move across the x-axis. And that relationship that we're trying to describe there, that leads us to the idea of a correlation. Okay, so this would be the scatter plot. Then if we want to actually describe the relationship between our x and y values, that would be a correlation. Okay. Now, a correlation describes a relationship between the two data sets, okay, between the two data sets. That does not necessarily mean causation, it just means that we see a general trend appearing between our x and y values, okay? Now, the three different types of correlations we can have are positive, negative, and then we could have no correlation. Okay? Now, a positive correlation is a relationship between variables x and y in which they both of them increase. Okay? Positive increase. So if we look at the scatter plot given to us here, if we look at the scatter plot here, notice as I go this way, as my x values increase, the y values are also increasing. As I move across the x-axis, y is becoming bigger. So as the x values increase, the y values increase. Okay, so they're both increasing. That would be a positive correlation. And notice if I made a general trend line through our data, the general trend line appears to be increasing as well. Okay? Now, in terms of a real-life example, okay, where might you have seen a positive correlation before? Okay? Well, one example might be if you're thinking about in terms of the summertime. Okay? In terms of the summertime, as the temperature starts to go up, ice cream sales also tend to go up because it's getting warmer outside. People enjoy cold desserts. Okay? So a correlation might be as the temperature goes up, ice cream sales also go up. Okay, so as the temperature goes up, that's going up, it's increasing. Ice cream sales also go up. That would be a positive correlation. Okay, now a negative correlation is a relationship between the two variables x and y again, where one of the variables increases. Okay, so one of them is increasing, while the other variable decreases. Okay, so as one goes up, the other goes down. Okay, so as the x value, let's look at our scatter plot. As the x values increase, so we're going from 0 to 10, notice the y values are going down, okay? So I'm starting at 1, it looks like, or even maybe 0.8 and a little past 8, maybe 8.7, this point over here, and then we end up with maybe 8.8, and then maybe 1.6 or 1.7 here. So as the x values are increasing, the y values are decreasing. Notice the general trend line here is that things are moving down, okay? So as the x values increase, the y values decrease. Okay, so that's the general trend there, is that as the x values increase, the y values decrease. Now, somewhere that you may have seen this before, maybe you're thinking about in terms of traveling in a car. Okay, if a car, let's say, decreases its speed, okay, let's say it's a car and we're decreasing our speed, travel time forgetting my L there. Travel time to a destination increases. Okay, so if we're talking about in terms of a car, so if we have a car that decreases its speed, you're slowing down, your travel time to the destination you're trying to get to is going to increase. Okay, so that would be an example of negative correlation. As one goes up, the other goes down. Okay. Then the last correlation we're looking at is no correlation. If we have no correlation, there is no way of determining from these points if the pattern is positive or negative. In other words, it's so scattered, there's no discernible way of telling if there's a general trend. Are things increasing together, or is one increasing and one decreasing? There's no discernible way to tell what's going on here. For instance, if we look at this guy here, these points are so scattered, we have no way of determining are things increasing, are things decreasing. There's just no way to tell here, okay? So a real life example of that might be like in terms of if you look at shoe size versus your IQ, okay? Different individuals that have high levels of IQ versus low levels of IQ are going to have different shoe sizes. They're not necessarily, there's no discernible relationship there. So we could say IQ versus shoe size. Okay, so there's no discernible relationship, whether it's a positive correlation or a negative correlation of IQ versus the size of shoe that you wear. Okay. So that would be the type of information that we want to cover in class in terms of being able to look at a scatter plot, being able to decide if there's a relationship within that scatter plot, a positive correlation, a negative correlation, or if there's no correlation.